In homework 6.1, we're working with transformed square root functions, and we're going to be finding a lot of things about them. The first thing it talks about is finding the domain and range. And before I find the domain and range, I don't do this on a paper, but I do make a little graph in my head of what it looks like. We know that this is a shift to the left by 5 and down by 3. So we've got a point there. And this negative 2/3, the 2/3 is going to vertically compress it. The negative is going to reflect it. And so we end up with, a square root graph that looks something like this. And, in my head, I basically got okay, well, it looks something like this, so I can find the domain and range. The domain, I'm going to write in interval notation. The domain is all the possible x values. And the x values here are the lowest x value is negative 5, and then it goes on to the right from there. So the domain is negative 5 to infinity, and I use a bracket on the negative 5 because there is an x value at negative 5. I always use a parenthesis on the infinity because there is no x value at infinity. The range, the lowest y value, when I look at this, it keeps going down forever, and so the lowest y value is actually negative infinity. Remember, we go from lowest to highest. And so the highest y value is negative 3. So the y values go from negative infinity to negative 3. So negative infinity to negative 3. That is my range. I'm not going to do the next domain and range for you, but I will make sure we understand what this transformation, the negative on the inside, remember, is a horizontal reflection. So again, it's shifted left by 5, down by 1. That's where the vertex is going to be. And the square root, instead of looking like the parent function, when there's a negative inside, that is a horizontal reflection. And so the square root graph looks something like this. It looks kind of like this. We want to get a quick graph for ourselves in our head. I'm not really caring about this number too much. It doesn't matter what the stretch or compress is, just what the domain and range are here. So you can see the domain is all the possible x values, and the range is all the possible y values. So I'll let you do that on your own, but I did want to make sure we had gone over this. Okay, transformations. Identify the transformations for each function and state 2 points. I'll do number 6. There's a bunch of transformations. Here are the shifts. So shift or translates. I don't care which word you use. Shift or translates. Left by 6 and down 4. This is 3/4 is less than 1. So vertical, because it's on the outside. Compression, because the number is less than 1, by a factor of 3/4. And this negative is not part of the compression. That negative, remember, is a reflection across the x-axis, because it is reflecting vertically. Now it says to state 2 points. One point that's easy is the vertex. When x is negative 6, y will be negative 4. There was a shift to the left by 6, and a shift down by 4. Now, the next thing we need to do is find another square root. And I think the easiest thing to do is just to go over 1. So 1 to the, when I picture it, it's 6 to the left, down by 4, looks something like this. I just need to find another point. And so when you're 1 to the right, there'll be an exact point because we can do the square root of 1. So when x is negative 5, I'll be able to do this because negative 5 plus 6 is 1. Square root of 1 is 1. Negative 3/4 times 1 is negative 3/4. And now we have to combine that with negative 4. Negative 3/4 minus 4. Notice I've just plugged in negative 5, evaluated the square root, and now I'm evaluating to do a fraction minus a whole number. We put the whole number over 1. And then we need to get a common denominator. And so we multiply by 4 over 4, which is a fancy way of writing 1. Multiplying by 1 doesn't change anything. And so we end up with negative 3/4 minus 16/4. This is another way of writing 4. And so we get negative 19/4. That's going to be my point. Okay. Graphing. I'm going to do one of these. Ooh, you know what? I'll do number 11, but I'm going to do it with the directions from later. Here it just says to sketch a graph. Okay, so we're going to do that. Later on it says to sketch a graph and label it as increasing, decreasing, and concave up, concave down. There's a really nice way of rewriting this. This is square root of 1/4 times x plus 6 minus 5. Remember that when you are, so we've got our vertex, it's going to be -6, -5. And remember that this, when it's on the inside, is a horizontal, and it's backwards from what it is. So you have to do 1 divided by 1/4 to figure out what it is. When you divide by 1/4, it's stretching it horizontally by 4. What that means is normally we would do square root of 1 is 1, but it's going to be 4 times stretched out horizontally. So it's going to be square root of 1, 2, 3, 4 will give us 1. The next thing would be square root of 4. But now it'll be square root of 16. Like you have to go all the way over by 16 before it gets up to 2. It's super stretched out. And we got this graph that looks kind of like this. Now this is one way to do it. There's a nice property of square roots, which is if you have square root of a times b, that's the same as square root of a, square root of b. And in this case, that's really useful because we have two things multiplying. 1/4 is multiplying times x plus 6. We can rewrite it as square root of 1/4 times square root of x plus 6. And we can do the square root of 1/4. What times what is 1/4? That's 1/2. And so another way to think about this is, again, the vertex would be -6, 5. And now it's a vertical compression by 1/4. So square root of 1 is 1. Half of that is 1/2. Square root of 4 would be 2. Half of 2 is 1. Square root of 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 3. Half of 3 is 1.5. So this is another way to do it. Now, this one, is it increasing or decreasing? Well, as you go from left to right, it's going up, and so we call that increasing. That's our vocabulary word for that. And then it is also concave. Remember, concave is about how it's bending. So notice this one is getting, the slopes are getting lower and lower and lower. Even though it's increasing the whole time, it's bending down, so it's concave down. It kind of looks like this part of a quadratic right here. And so the slopes are actually getting lower and lower and lower. There is not a constant rate of change. The rate of change is decreasing. So this one is increasing but concave down. Something like this would be decreasing but bending up. Something like this would be decreasing, you read from left to right, decreasing and concave down. So that's what's going on there. Hopefully that's helpful.